Alright, so in this video we're going to solve the paper 2 of May-June 2020, and we have here question number 1. So let's get straight to it. So question number 1 says that Stephen had an annual income of $21,500 in 2018. His annual income increased to $22,790 in 2019. And we have to find the percentage increase. So percentage increase, or whether it's percentage change, or whether or even if it's decrease, it's calculated through the same formula, and that is you figure out the change, or you can say the new minus old value, divide by the old value, multiplied by 100. So if I want to figure out the change, I'm going to take 22,790 and from it I'll subtract 21,500. I'll divide it by the old value, which is 21,500, and then multiply it by 100 to get the final answer. So let's see what do we get. 22,790 minus 21,500 divided by 21,500 multiplied by 100. So the answer is 6%. Okay. Now let's do part B, which says Stephen invests $1,260 in a bank. The bank pays simple interest at a rate of 2.5% per year. Calculate the amount Stephen has in the bank at the end of 3 years. Now the reason why I'm emphasizing on this is because we have to give the total amount. Now before we can do that, of course, we have to figure out what is the interest earned during this 3 years. So the principal amount is 1260 multiplied by the rate, which is 2.5, multiplied by the number of years, and then divide by 100. Basically the formula that I'm using is this, that simple interest is equals to principal amount, which is the amount that you invest in a bank, and multiplied by the rate, which is 2.5% here, multiplied by the time, which is 3, and then divide by 100 for percentage. So let's work this out. 1260 multiplied by 2.5 multiplied by 3 divided by 100, and the answer here is 94.5. But let's not get carried away. 94.5 is not the final answer. For the total amount, I will take this 94.5 and add it to 1260. So let's figure that out. Plus 1260. So that gives me $1354.5. Alright, now let's do part C, which says Stephen changes 4,300 Indian rupees into dollars. The exchange rate is $1 is equal to 67.8 Indian rupees. Work out how much he receives. Give your answer correct to the nearest dollar. So that means we have to give our answer correct to the nearest integer. So let's make a column for dollars and let's make a column for Indian rupees, INR. So $1 is equivalent to 67.8, and we're going to write 4,300 under Indian rupees and X under dollars. So let's cross multiply. So basically X can be found by taking 43,000 and dividing it by 67.8. So 43,000 divided by 67.8 is going to be equal to 634.2, and since we have to give our answer correct to the nearest dollar, we'll just lock it at 634. Okay. Let's do question number 2, which says the length of a rectangle is 6 centimeter more than its width, W centimeter. The perimeter of the rectangle is 37 centimeter. Form an equation W and solve it to find the width of the rectangle. Okay, so if the width is W and the length of a rectangle is 6 more, so what's 6 more than W? That's simply going to be W plus 6, and the perimeter is 37, so this length will also be W plus 6, and this will be W. So twice of the length plus width, so W plus 6 is the length plus the width, which is W, is going to be equal to 37. So let's work this out. W and W will give us 2W plus 6. Now let's divide 37 by 2, so that's going to be 18.5. Now let's solve for W. So 2W is going to be equal to 12.5, and W is going to be equal to, let's find out, 6.25. So 6.25 is our final answer. Let's just make sure that we have to find the width. Yeah, we have to find the width. Okay, now let's do part B, which says a rectangle 20 centimeter by 8 centimeter is cut to form a rectangle 28 centimeter by 15 centimeter. Each measurement is given correct to the nearest centimeter. Okay, calculate the upper bound for the area of the shaded region. Alright, so if I want the upper bound for the area of the shaded region, so the formula that theoretically, this is what we're going to do. So basically the shaded area will be equal to the area of the larger rectangle minus the area of the smaller rectangle. Okay, so when I'm calculating the area of the larger, since I want the shaded region to be as great as possible. Now the example that I want you to think of is this, that suppose what's profit equal to? Profit is basically equal to selling price minus cost price. Now suppose you want to maximize your profit by manipulating the sale price and the cost price. So you would increase the selling price and you would decrease the cost price. Why? Because cost price is going to be deducted from the selling price. So you would want ideally to deduct a value that is as less as possible, and you would want that the value that you're deducting from, which is the selling price, is as great as possible, so that the leftover amount, which is the profit, is as high as possible. So if I want the shaded area to be as great as possible, I'll have to take the upper bound of the larger rectangle and I'll have to take the lower bound of the smaller rectangle. So the dimensions that we have here are 28 by 15 of the larger rectangle. Now since they're both correct to the nearest centimeter, so that means the upper bound of 28 is going to be 28.5. And how did I figure that out? So we have 28 here, right? This is correct to 1 centimeter, so I'm going to divide 1 by 2, which is 0.5. If I want the upper bound, I will add 0.5 to 28, and if I want the lower bound, I will subtract 0.5 from 28. And this applies to every other length. So 15.5 will be the upper bound and 14.5 will be the lower bound. 20.5 will be the upper and 19.5 will be the lower. 8.5 upper, 9.5 sorry 7.5 the lower bound. So if I want the area of the larger rectangle to be as great as possible, so that means I'm going to take the upper bound of the length and the width. So I'm going to take 28.5 and multiply it by 15.5. So 28.5 multiplied by 15.5, that's going to give me the upper bound, and from this I will subtract the smaller rectangle and I'll make sure that the area of the smaller rectangle is as less as possible, meaning that I will use the lower bound of the length and the width. So 19.5 multiplied by 7.5. So let's work this out and see what do we get. So 28.5 multiplied by 15.5 minus 19.5 multiplied by 7.5. So the final answer here is 295.5 centimeter square. Well, we don't need to write centimeter squares, and that's all. Since, oops, sorry, not 2.5, and we don't need to write centimeter square since that is already written. Okay. Now we're at question number 3, which says a light L is fixed on a building 8 meters above the base B of the building, and we have a point P is on the horizontal ground 12 meters from B. All right. Calculate the angle of elevation of L from P. All right. So that's quite an easy question. So this angle that I've labeled theta is what we have to calculate, and we have to do this with the help of the opposite length and the adjacent length. So that means that the trigonometric ratio that I'll use will be tan. So tan theta is equals to 8 upon 12. So let's work out theta by taking the tan inverse of 8 upon 12. So tan inverse of 8 divided by 12 is giving me 33.69. So I'm going to lock it at 33.7. And remember, if you have to give any angle, you have to give it correct to 1 decimal place, irrespective of the number of significant figures. Okay, now here we are, and here we have to calculate QL. Okay, so again we have a 90-degree triangle, and this is basically a ladder that's placed. It's making an angle of 70 degrees from with the ground. So if I want to calculate QL we can see is the hypotenuse length. The length that's provided to us is the opposite length, so that means we'll have to use sine. So sine 70 is equals to 8 upon QL. So let's work out QL. That's going to be equal to 8 upon sine 70. So let's work this out. 8 divided by sine 70. So we have 8.51 centimeter or meter. What unit are we using here? Actually, we don't have to worry about that since that's already written. So 8.51. It's got to be centimeter. We can't have a ladder that's 8.51 centimeter. It doesn't make sense. Okay. Now let's do part C. Let's see what we have. We have a vertical pole RS. Okay, so here's the vertical pole that we can see. Is of length 1.6 meters and is placed touching the horizontal ground. The light produces a shadow TS of the pole on the horizontal ground. LRT is a straight line. Okay, and TB is equals to 6.5. So what do you have to calculate? We have to calculate TS. Alright, so since RS is also a vertical line, so that means here we're going to have a 90-degree angle. Alright, and if I want to calculate TS, let's see if this is the same as the one. No, it's not. Okay, so what we're going to have to do here is that we're going to have to apply similar triangles. Yeah, that's the only thing that makes sense. So I'm just going to redraw this these two triangles. So we have a 90-degree angle here. We have RS here. This is 8, this is 1.6, and this entire length is 6.5. So if this entire length, this is T, this is P, yeah. So if this entire length is 6.5, so let's call this X, and the two similar triangles are triangle LTB is similar to triangle RTS, and the reason for that is very simple. Basically, this right here is a 90-degree triangle, so we can see that these two angles are the same and they share a common angle, which is angle T. So this angle is the same for both the triangles, and since these two lines are parallel, line RS and LB, so that means this angle TRS is going to be the same as angle TLB because of corresponding angles. Okay, so let's take LT. Let's see, do we have LT? No, we don't, so we're just going to ignore that, and for the same reason we'll ignore RT. So we're going to start off with TB. So we have TB, and then we're going to divide it by TS, and this ratio is going to be the same as LB upon RS. So what's TB? TB we can see is 6.5. What's TS? Well, we don't know. In fact, that's exactly what we have to figure out. This ratio will be the same as LB, which is 8 upon RS, which is 1.6. Now let's cross multiply and see what do we get. So TS times 8 is going to be equal to 6.5 times 1.6. So TS is going to be equal to 6.5 times 1.6 upon 8. So I'm just going to punch this in my calculator. 6.5 times 1.6 divided by 8. So that gives me 1.3 meters. So there you have it. That was question number 3. Now let's do question number 4, where we have a table which summarizes the time m hours that each student in a year group spent listening to music in one day. Okay, so fine, we have the data in front of us, and here we have a frequency density diagram, or basically we have a histogram. Okay, so in a histogram, on the y-axis we have frequency density, which by the way is equal to frequency upon the class width, which is basically the difference between the higher value and the lower value. Basically, like the class width of this is going to be 1 minus 0. Now if you want to figure out what the frequency density is, we've just figured how to do that. And also, if you want to learn how to plot a histogram, I have a video on it, and you can search for it. You'll probably find it in the statistics playlist. Okay, now so we have to find the value of P. So let's see what is P representing. So P is basically from 1.5 to 2. So this right here, so this is basically the bar for this particular range. So the frequency density here we can see is 30. So that means 30 should be equal to the frequency, which is P, divided by the class width, which is basically the difference between 1.5 to 2, and that is 0.5. So with the help of this, I can figure out what P is equal to. P is going to be equal to 30 times 0.5. So 30 times 0.5 is going to give me 15. So the value of P is 15. So we have to complete the histogram. All right, let's just do that. We have the first 3 bars plotted. So 1, 2, 3. This is done. So let's figure out the frequency density for this one. For this, we will have to take 14 and divide it by what's the difference between 2 and 2.5? That's 0.5. So that's going to give me 28. Okay. So let's plot this. Let's try and use straighter lines. Actually, let's figure out the frequency densities for every value, and then we're going to plot them. So for this, we're going to take 23 and divide by 1, which will be equal to 23. And for this, we're going to take 18 and divide by 1.5. So let's figure that out. Should be 12, but let's just double check. Yep, that's 12. And for this, we're going to take 12 and divide by 2, which is equal to 6. So now that we have the frequency densities in front of us, it will be a lot easier for us to plot the histogram, to complete the histogram. So for 2 to 2.5, our frequency density is going to be 28. So 2 to 2.5, our frequency density is going to be 28. So here's 25. And since 5 units is split between 10 small boxes, so that means 2 small boxes will make 1 unit. So this is 27, 27.5, 28. So there you go. And then let's turn this left to close it. Okay. And then for the next one, 2.5 to 3.5, it's going to go up till 23. So 2.5 to 3.5, 23. So here's 20, here's 22.5, and here's 23. So there you go. And then for 3.5 to 5, the frequency density is going to be 12. So 3.5 to 5, the frequency density is going to be 12. So here is 12, and there you go. And then for 5 to 7, it is going to be 6. So 5 to 7 is going to be, so here's 5, 2 blocks above is going to be 6. So there you go. Okay, so we've completed the histogram. Let's do part B, which says the table summarizes the time, hours that each student in a group of 50 students spent cooking in 1 week. Calculate an estimate of the mean time spent cooking. Alright, so whenever you have data in range form or in interval form and you have to figure out the mean, so the first thing that you should do is you should figure out the midpoint for every range. So 0 to 2, the midpoint is going to be 1. For 2 to 4, the midpoint is going to be 3. 4 to 6, the midpoint is going to be 5. 6 to 8, the midpoint is going to be 7. 8 to 10, the midpoint is going to be 9. So if I want to figure out the mean, so that's going to be 1 times 8 plus 3 times 16 plus 5 times 15 plus 7 times 7. So basically what I'm doing is this, summation fx divided by summation f. So what I'm doing is I'm multiplying the frequency by x, which here is the midpoint of the times, and then I'm adding them up one by one, and then once I'm done with that, I'll divide it by the total frequency, which I can extract from the question, and that is 50. Plus plus 9 times 4, yeah, since that's the only thing left. Okay, so then I'm going to divide it by 50, so I'm just going to do this in my calculator. So 1 into 8 bracket close plus 3 into 16 bracket close plus 5 into 15 bracket close plus 7 into 7 bracket close, 7 into 7 plus 9 times 4 bracket close. So this is equal to 216, the numerator, divided by 50. Let's work this out. So this is equal to 4.32 hours. Okay, now we have to draw a cumulative frequency diagram. So in order to draw a cumulative frequency diagram, first let's clear the mess that I've made here. Okay, so a cumulative frequency diagram, as the word itself is quite self-explanatory, is drawn by adding the frequencies. Now how do you add the frequencies? So the number of students who spent 2 hours or less is equal to 8, and when drawing a cumulative frequency we just focus on the higher value. That means if I want the number of students who spent 4 hours or less listening to music, so that's going to be this 16 and this 8. So 16 plus 8 is equal to 24. So what we're doing is we're accumulating them. And then if I want the number of students who spent 6 hours or less, so that's going to be 24 plus 15. So 24 plus 15 is going to give me 39. And then for 8 hours and less is going to be 39 plus 7, which is going to be 46. And then we'll have 50. So now that we have the cumulative frequency, we're gonna plot them we're gonna mark them one by one. So 2, 8 will be 1 point, 4, 24 will be the other, 6, 15 will be the third, 8, 46, sorry, not 6, 15, 6, 39, 6, 39, and then 7, 46, and then, sorry, not 7, 46, my bad, 8, 46, and then 10, 50. Okay, so 2, 8, let's mark that, 2, 8, and then we have 4, 24, so 4, 24, and then we have 6, 39, so 6, 39, and then we have 8, 46, so 8, 46 will be here, and then 10, 50. Okay, so let's just plot them with a smooth curve, and don't forget to join it with 0. So there you go. Yeah. Alright, now the question says use the cumulative frequency diagram to find an estimate for the median. Alright, so what's the median? Median is basically 50% of the total frequency, which is 50. So 50% of 50 is going to be 25, but don't get carried away. 25 is not going to be the final answer. It is the corresponding value of 25 that is going to be the final answer. So this approximately is between 4 and let's see, what do we have? 4 and 4.2, right? So I'm going to log this at 4.1, and hopefully this is inside the acceptable range. Alright, so now let's solve question number 5, which is simultaneous equations. It's a very easy topic. And the method that I'm going to use is elimination. So I've decided to eliminate y because one is already negative and the other is positive. So we can see that we have 4 and 3 as our coefficients, negative 4 and 3 actually. So I'm going to turn both of them into 12, actually one of them into negative 12 and the other into 12. So that means I'll have to multiply the first equation by 3 and the second equation by 4. So we have 6x minus 12y equals to 33, and then we have 12x plus 12y equals to, let's just write that again, equals to minus 24. Make sure that you multiply all three values. So 33 minus 24 is going to give me 6 and 3, that's 9. This will get eliminated, which is exactly what we wanted. 12x plus 6x is going to become 18x. So x is equals to 9 upon 18, which is equal to 1 upon 2. So we have the value of x right away. And now let's figure out the value of y. So I'm going to use the first equation. So 2x minus 4y equals to 11. So I'm going to plug in half in place of x, minus 4y equals to 11. So let's work this out. 2 and 2 get cancelled out. So 1 minus 4y equals to 11. 1 minus 11 equals to 4y. So 4y equals to negative 10. And y equals to minus 10 upon 4, which is equal to minus 5 upon 2, or 2.5. So minus 5 upon 2 is the value of y. Okay. Now let's do part B, in which in which we have a quadratic equation. So let's first write it nicely. 2x squared equals to 24 minus 3x. So we have 2x squared plus 3x minus 24 equals to 0. Now whenever you read the question and see that it says correct to 2 decimal places, so don't try and waste your time trying to solve this with the help of middle term breaking. Straight away use the quadratic formula. So the quadratic formula is x equals to minus b plus minus square root of b squared minus 4ac upon 2a. Alright, so a, as you can see, is equal to 1, b is equal to 3, and c is equals to minus 24. So if you're using an advanced calculator, you can solve this in your calculator directly, but use that feature just to check your answer, and make sure that you show the working. So, and by working I mean make sure that you show this, what I'm about to write. So minus 3 plus minus square root of 3 square minus 4 into 2 into c, which is negative 24 upon 2 times 2. Alright, so once I've written this, then I'm going to use the feature in my calculator in order to get the final answer. So let me just do that quickly. So one value is equal to 2.79. Make sure that you give your answer correct to 2 decimal places, and the other value is equal to minus 4.29. So there you have it. We have solved question number. What question number is this? Question number 5. Yeah. Oh no, we haven't. There's another part. So here we have h, which is inversely proportional to the cube of g. So that means h is equal to k upon g cube, and h is equals to 4.5 and g is equals to 2. So 4.5 equals to k upon what's g? G is equals to 2. So let's not forget to cube it. So if I want the value of k, I'm going to take 4.5 and multiply it by the cube of 2, which is equal to 8. So let's work that out. 4.5 multiplied by 8. So k is equals to 36. Now that I have the value of k, I can find the formula. So I'm going to replace k with 36 and g cube as it is. So h is equals to 36 upon g cube. Find the value of g when h is equals to 32 upon 3. Alright, so h is basically equal to 36 upon g cube. So in place of h, I'm going to plug in 32 upon 3 and set it equal to 36 upon g cube. So let's work this out. G cube is going to be equal to 36 times 3 upon 32. So let's evaluate this in our calculator. 36 times 3 divided by 32. So g cube is equals to 27 by 8. Now if I want the value of g, that means I'll have to take the cube root on both sides. So that's going to be equal to 3 upon 2, since the cube root of 27 is 3 and the cube root of 8 is 2. Okay, now let's do question number 6, which is, let's see, 2 of these cards are chosen at random. They are placed next to each other to give a 2-digit number. Find the probability. Okay, so this deals with probability that the 2-digit number is less than 30. Okay, So if I want the number to be less than 30, let's see all first of all, let's see the total possible numbers that we are going to have. So the total possible numbers are going to be, well, when you're choosing the card for the first time, you have 5 options, and when you're choosing a card for the next time, you have 4 options. So that's equal to 20. And let's see the total number of numbers that I can form that are going to be less than 30. So one of them is going to be 24, the other is going to be 26, and then we're going to have 23, and all the rest of the numbers are going to be greater than 30, since the only units, since the only tens that we have which is less than 3 is 2. So that's 3. So our favorable outcome is 3, and the total outcomes is 20. So our answer is going to be 3 upon 20. Okay, list all the possible 2-digit numbers that are prime. Okay, so all the 2-digit numbers that are prime, let's see. So if we have 5 in the first place, and if we have 3 in the second, so 53 is going to be a prime number, is it? Yeah, 53 is going to be a prime number. Okay, and then if we have 2 in the first place, and then we can't have 5, we can't have 4, we can't have 6, and if we have 3 in the second, so that's also going to be a prime number. Okay, and then if we have 4 in the first place, and then if we have 3 in the second, so 43 is also going to be a prime number. Yeah. And then if you have 6 in the first place, you can't have 5, that's not a prime number. You can't have 2, obviously it can't be an even number. You can't have 4, and you can't have 3, so that goes out the window. So if you have 3 in the first place, and let's see, if you have 35, that's not a prime. 32 is also not prime, 34 is also not prime, 36 is also not prime. Yeah, so basically we have 3 prime numbers, and what do we have to do? Do we have to find the probability? No, we just have to list all the possible 2-digit numbers that are prime. So we have 53, we have 23, and we have 43. Find the probability that the 2-digit number is a multiple of 4. Alright, so let's see how many multiples of 4 we can come up with. So if we have 5 in the first place, we can have 2 in the second, that's going to be a multiple of 4. We can have 56, which is also going to be a multiple of 4. And if we have 2 in the first place and 4 in the second, so that's going to be a multiple of 4. And if we have 2 in the first and 6 in the second, that's not going to be a multiple of 4. So let's try out with 4 as our tens. So if you have 4 in the first place and 2 in the second, let's see. No, this will not be a multiple of 4. And if you have 4 in the first and 6 in the second, nope, that's not going to be a multiple of 4 either. So 43 obviously is an odd number. Okay, so let's try it out with 6. So if you have 6 in the first place and 2, no, that's not, 62 is not a multiple of 4. 64, however, is a multiple of 4. And finally, let's try it out with 3. So if you have 3 in the first place, 32 is going to be a multiple of 4, and 36 is also going to be a multiple of 4. So how many multiples of 4 do we have? We have 1, 2, 3, 4, 5, 6. So 6 divided by 20, which is equal to 3 upon 10. And that's going to be our final answer. I think a good way to solve this question would have been to first list down all the possible outcomes. I think that would have been a nicer way to do this. But yeah, it really doesn't matter. Okay. So part B says Roman throws dice 200 times. The bar chart shows his results. Okay. Use the bar chart to complete the table of results. Okay, so we just have to read the frequency and write it in the table. So the frequency of 4 is halfway between 30 and 40, so that's got to be 35. The frequency of 5 is not halfway. So let's see, we have 10 units that are split in 10 small boxes. So that means every unit is responsible for 1. So this is going to be 21, 22. So that means the frequency of 5 is going to be 22. And then the frequency of 6 is going to be 2 less than 40. So that means this is going to be 38. Okay. So ideally, if you want to check your answer, you should sum up the frequency and it should turn out to be 200, since the total number of times he has thrown the dice is 200, as we can see in the question. So I'm going to do that just to be safe. 46 plus 31 plus 28 plus 35 plus 22 plus 38 should be equal to 200, and yep, it is. Using Roman's result, find the relative frequency that he threw a number less than 3. Alright, so less than 3 means it can be a 1 or a 2. So basically I have to find the probability that his score is less than 3. So 46 plus 31 is equal to 77. So I'm going to divide this by 200. And since I can't simplify it any further, so 77 upon 200 is going to be my final answer. Okay, now in part 3, let's see what part 3 says. It says, Rowan says that the dice he has thrown is not a fair dice. Make 2 comments to explain why the dice may not be fair. Okay, so when we're testing out how fair a dice is, it's always best to test it multiple times. Like for example, you can't test it 10 times, 20 times, or even 50 times. Okay, so we can see that this dice has been tested how many times? This dice has been tested 200 times. So that's enough times to decide whether a dice is fair or not. And even after testing it 200 times, we can see that the difference in the frequency is fairly significant. Okay, so one reason that we're going to say that this dice may not be fair is because, so one reason that we're going to give is that the total frequency or the total number of times it has been tested is fairly large. Okay, is, whoops, sorry, that's not how you spell fairly, is fairly large. Okay, and reason number 2, we can do it with the help of a bit of calculations. We can see that if it were fair, so the frequency of any, sorry, the relative frequency of any value on the dice should have been equal to 1 upon 6. So for example, we can see that the relative frequency of 1 is going to be 46 upon 200, which is definitely not equal to 1 upon 6. So we can say that 46 upon 200 is not equal to 1 upon 6, or you can give any other value. You can say that let's say 31 upon 200 is also not equal to 1 upon 6. Why? Because if it were a fair dice, the relative frequencies would have been equal to 1 upon 6, or if not exactly equal to, they would have been close to 1 upon 6, but that's not the case clearly. So that's all for this video, and in the next video I'll solve the remaining parts of this paper. So I'll see you guys then. Until then, take care. Bye bye.